Home automation is a popular topic these days and with good reasons. Devices that we use in the home can be connected to the internet and controlled remotely via an app or voice assistant. This means you don't have to control them manually each time you want to turn up the thermostat, close your curtain, or water your plants. Today, I will show you how to make an IoT-enabled plant watering system for indoor as well as outdoor plants using Arduino's IoT features. Arduino Nano 33 IoT is the most straightforward and least expensive way to turn your old projects into part of the IoT and build Pico network apps and even create new ones. There is an inbuilt Wi-Fi adapter that will work flawlessly with all the projects. That means you won't have to use an external Wi-Fi module. The water pump I used is a 12-volt DC pump which can be purchased from your local hardware store. The water valve can be bought from your local hardware store for around 20 rupees. Solid-state relays are simple and reliable electronic switches that allows you to control high-voltage devices with low-voltage signals from your Arduino or other microcontrollers. I will be using 4 SSRs to turn on and off different pumps. Now, let's take a look at the circuit. I used Altium Designer to draw the circuit and design the PCB. It's a powerful tool that can be used to design and create your own PCBs for your project as well as complex and multi-layer PCBs for industrial use. I will leave the link to the free trial version in the description. Also, if you are planning to buy it, there is an awesome 30% discount by purchasing it using the link below. So, do make use of it. The board has 2 voltage inputs, one for the Arduino and other components and another for driving the electronic devices connected to the relay. In our case, the pumps. Here, I'll be connecting a 12-volt DC adapter to power the pumps. A 7805 voltage regulator is used to regulate the input voltage. The 7805 voltage regulator is a 5-volt regulator which converts an input voltage of 7 to 32 volt to a constant 5-volt DC supply and is fed to Arduino and other components. And there are some LEDs for easy troubleshooting. As I mentioned earlier, here I used SSR or solid-state relays, but you can use mechanical relays as well. Just make sure you add a relay driver. After the circuit was created and tested, I designed a compact PCB using Altium where I can fix all the components neatly. Here, you can see routing is on both sides of the board, which means it's a dual-layer PCB. I will provide the links to the Gerber file in the description. I ordered my PCBs from PCBWay. PCBWay is a PCB manufacturer specializing in PCB prototyping, low-volume production, as well as neat and tidy PCB assembly. To order your PCBs from PCBWay, go to PCBWay website and fill in the basic board details in the instant order form. From there, you will be directed to a form where you can provide more elaborate board details. Update your board information in the PCB specification screen, and on the next screen, you should be able to upload your Gerber file and submit it for a review. Once the review is completed, all that is left to do is add to cart, make the payment and wait for your PCBs to arrive. Once you get all the components and the PCBs, it's time for you to solder them together. Solder all the components onto the board and make sure to check the polarity of the components before soldering. After soldering, the PCB looks like this. Next part, coding. This tiny board can be readily programmed using most user-friendly open source platform, the Arduino. This will be discussed in further detail. So to start with, download and install Arduino IDE from here. So let's take a look at the code. This is where we enter the SSID and passphrase of your network. And this is the port Arduino will be listening to for UDP packets. These 4 pins here will be connecting to the relay input. Here, we will connect to the Wi-Fi network using predefined DSSID and passphrase and set up a UDP listener in the predefined port. Save the UDP packet's content to the variable packet buffer and print its value. And we turn the output of the pins to high or low depending upon the packets received. RootSet Wi-Fi Command Center is a simple and lightweight Android application that can be used to control robots and home devices using Raspberry Pi and Arduino over Wi-Fi. All you have to do is connect your mobile phone to the network, enter the IP address and port of the server, and control it using on-off buttons. You can simply download it from Play Store. Now, all you have to do is start the app, enter the IP address of the Arduino and port it is listening to, then load the IP address and port using the link button and navigate to Home Automation tab. If you want, you can open Serial Monitor and check whether all the commands are received successfully. At this point, you should be able to turn on and off different pumps using these buttons. If you have any doubts regarding this project or any electronics projects, make sure you ask it in the comments. And do subscribe to our channel to see more videos like this. See you in the next video.